Hello, Geometric Physics. Here's our quiz that we took today. I said I would go through the first version of this quiz. So as you notice here, it's quiz 2. So if it was the retake, it would say retake after it. So this is our original quiz that we took. And I would just like to go through how we do each of these particular problems then. So for the first one, it asks us to create a quantitative velocity time graph. Okay, sorry. For this particular quiz then, we were looking at making a velocity time graph of the following motion. And we want to show any calculations that we do to get our slopes. That should clue us in on how to solve this next problem. So first thing that I want to know, if I'm looking at the slope of this particular line right here, how do I find slope? So we can find slope as doing our y2 over y1 x2 minus x1. Or we can look at slope as rise over run. In this case, why don't we look at rise over run? So here's where my point started. And if I look where the next point is, it went down a total of 1, 2, and now when I look at it going over, it went over 1, and it went over 2. So if I'm looking at this, it's a rise of 2 over a run of 2, so I get a slope of 1. Notice the direction of this line, so we do get a negative 1. For our next line, let's go ahead and find the slope of it. So it starts down here at a negative 2. It goes up to a negative 1. It goes up to 0. It goes up to 1. So how much did it rise up? It rose up 1, 2, 3. So this has a rise of 3, and it went in a 1 second interval because this dot is at 2 and this dot is at 3. So this line is a slope of 3. Now we get to the next line, this segment right here. Notice that this segment is flat. Flat should automatically clue us in to it has no speed. It didn't move. Very last part then, if we do the rise over run, so it rose 1, and it ran from 6 to 7, so it ran over 1. Notice again that the line went down, so it would be a negative 1. These are the numbers that we are going to put onto our velocity time graph. So here we're going to say that the slopes are going to go on our velocity versus time graph. So now you want to know, okay, how do I number this thing? Well, we want to number it so that we include 3. So let's go by ones. So 1, 2, 3, and I'll number down 1, negative 2, and negative 3. So if I'm looking at this first part here, time-wise, for 2 seconds, it was at a slope of negative 1. So for 2 seconds, I'm going to draw my line going straight across at negative 1. Then from 2 to 3 seconds, it had a slope of 3. So now I need to go all the way up to the 3 line, and from 2 to 3 now, I'm drawing my flat horizontal line to show that it has a slope of 3. My next thing, if I'm looking, my next one, I need to go to the 0 line. But how many seconds did this object stay at the 0 line? So it started at 3 seconds, and it stopped that motion at 6 seconds. I need to show the same thing over here. So starting at 3 and ending at 6, it's going to be a flat line at 0. And if we want to connect them, we can do our dotted line connection. Last part then, last little bit here, we calculated our slope and said it was a negative 1. How long did it do a -1 slope? What was our time frame? So this line starts at time 6, ends at a time of 7. So from 6 to 7, we are going to have a -1 slope. So here's how we do our first one. So things just to sort of jot down of how do we do this. So stepwise. Steps that we need to do to go from a position time graph to a velocity time graph. So step number 1 is find the slopes. That's going to be your very first step, is find the slopes of each line that changes direction. Step number 2 is going to be then label your velocity versus time graph. Put the numbers on. That's what we did next. We added the numbers. Step number 3 then is going to be look at the times. So look at how long did it do each one of those slopes that you just calculated. So then we took those and we put the numbers onto this graph. So notice this only goes up to 7. Yours should also stop at 7. So we don't want it to extend it any longer than our previous one was. Alrighty, number 2. Number 2, we need to create a motion map. So a couple things note-wise with a motion map. All right, first thing, the number of dots. So the number of dots equals, all right, your number of seconds plus 1. And why do we think 1 additional dot? We have 1 additional dot because we have to show that at 0 seconds it had a starting point. So your number of dots for this one, if we look, there are 6 seconds. We should have a total of 7 dots. So in this case, we're going to have 7 dots for this particular motion map. The next thing with our motion map is this line here with the arrow is the same exact thing as our position on the side. So let's go ahead and put down our ranges just like what's on our position over here. So it goes 0, 20, 40, 60. So we'll say 0, 20 meters, 40 meters, 60 meters, and that's all the higher it goes. So when we do a motion map, the first thing we want to do is at each time interval, put a dot. At 1 second, put a dot. At 2 seconds, go up to your line and put a dot. At 3 seconds, go up to your line and put a dot. At 4 seconds, at 5 seconds, at 6 seconds. Now what you're doing is each one of these dots that you just made is going to go onto your motion map. So at 0 time, he was at 20 meters. So this is my first dot showing that this is 0 seconds. At 1 second, what position was he? Still in the same position. So you're going to stack the dots, and this is your 1 second. At 2 seconds, go up to your line, and he was at 40. So at 2 seconds, we're going to put our dot, and I'll put a 2S just so we keep track. And because he's in motion from 1 to 2, we got to put the arrow. We only put arrows when it's actually in motion. When it's standing still like these two, there is no arrows. An arrow is representing motion. So 2 seconds is what we're at. We need to go to 3. Go up to 3. he's at 60. So third second is going to go at 60. Fourth second, go up, still at 60, so I stack the dot above it. And I'm putting the seconds next to them just so that we can keep track of where are we. At 5 seconds then, at 5, we're kind of estimating. He's maybe at 45, so we'll go down and maybe put it about right there. And notice that the direction changed. It's now heading down, which means towards. So my arrow, notice it's going back towards my start point. So this was dot 5 seconds. Now I need one more because I need 6. So I go 6 and he's at 20. So 6, I put it at 20. And this is now my 6-second dot. So things to help us with motion maps. So just like we created steps up here for these, let's create some steps or think through this problem. So steps that we can do for our motion maps. Step number 1 is going to be put a dot at each second. So that was the first step we did. We went through and we put a dot at each one of the seconds so that we know where they are. Step number 2, we're going to put dots on motion map. Put dots on motion map based on position. And step 3 then, we're going to draw the arrows. So those are our 3 basic steps for doing our motion maps then. So put a dot at each second. We put dots here. Step 2, put dots on our motion map based on position. So we started and we went at 0 seconds, they're at 20. At 1 second, he's still at 20. At 2 seconds, he's at 40. And you can see how we progressed through each one of those dots. Step 3 then, make sure you draw your arrows. All right, last and final problem number 3. For this one, so we changed the words over here to say starting at 4 meters. So first thing that we want to do when we're dealing with a velocity time graph is step number 1. All right, let's do the steps first. Let's see if I can actually get to write properly here. So steps then. Step number 1. First thing we want to determine is displacement. We want to know how far did he travel in each interval. So step 1, determine displacement. We determine displacement by finding the area. So if I go, here's my first line, here's the second line, here's my third one, and here's my fourth one. So this first line, if I draw a box, it's going to come down to 2, and this is how far he goes the first time interval. So notice that if I look at the side, it's 1, 2 high, times 1, 2 wide, so 2 times 2. During this time interval of 2 seconds, he's going to go a total of 4 meters. Next box. Next box is only 1 high, so 1 times, now it goes from 2, 2 to 3, 3 to 4, 4 to 5. So 1, 2, 3. This one, he's going to go a total of 3 meters. The next line down here at the bottom, so we're going to take that box, draw it all the way up. So now we're looking at this particular area. So if I look as far as the height goes down by 2, So 2 times, and this